Hey, John here. What does it mean when somebody says read the fine manual? They're usually referring to something like this. This is one of the, I don't know, six or so volumes of the Berkeley Unix software distribution of Unix, okay? And these manuals these are the actual ones I think I had in graduate school based on the dates, and some of them have highlighting and so on in them. It says copyright 1986, so that's right for me. Anyhow, these are off the back part of my bookshelves, and I still have them. And I'd like to give you the opportunity to get a kind of an understanding of first how the manuals are really put together and why some of these old ones are still kind of pretty useful. All right, so in the beginning, we had these. These are the BSD Unix. These are from like 4.3 BSD Unix back in 1986, as we can see here. So these are the manuals that I probably used when I was in graduate school in the mid 80s. And this is the whole set. You have the master index. This is the index, the table of contents for all these books combined. So you don't have to know in advance which book has the item you're looking for in there, and you can find out whatever your output tabs are described in NROF in section 1 of the manual. This suppress formatted output in Unix supplementary documents, section 24, page 2. Okay, so you end up seeing this notation, and if you've ever been on the internet, you may have seen these like P open with a 3 in the parentheses just there. That means that this is a command in section 3 of the manual. And if you knew what section 3 is, you would know that that's a C library function. And the sections in the a priori knowledge of which section is what comes from these manuals and the Unix System 5 manuals as well. They all started with Unix. That particular notation did anyway, all right? So let's look at what's in each one of these things. All right. System manager's manual is going to be filled up with, how to install the operating system and how to, do what commands are used to deal with certain functions. How do you format a hard drive? All that sort of stuff was in this manual here. And all these commands, like how to reboot the machine, for example, in here. And all this is what we call, in section 8 of the manual, which is the system manager's manual here, which is, of course, described by an introductory page for section 8 of the manual. And it says in here, this is an introduction to system maintenance and operation commands that related to system operation and maintenance. It describes commands, how to create file systems, etc., etc. Okay, so that is section 8. Now, I'm jumping around because this is just the top book. I just drew them down here so you can see them all. So this includes sections 8, and then there's a bunch of other tabs in here. These are probably various papers that have been written by, well-known names over the years. So what do we got here? This is how to install and operate SendMail, which was basically the only email system that the entire internet used, honestly, up until, I don't know, you had some pretty lame ones that came along in the 90s, and nowadays there's a couple of good ones after 2000, okay? Time Demon, how to deal with keeping your clock synchronized, right? Lots of stuff. Oh, Usenet, right? Before we had the World Wide Web, we had Usenet, and you needed that. That's where all the articles and stuff would come from. How do you send messages around? It was all text. And it was basically email messages that would go to large mailing groups, if you don't know what that is. Anyway, a bunch of commands on how to operate run the operating system as a whole is in that section here. Now, why paper? All right. Paper was far more useful than having these only online, because back in the day, if you would have access to a computer is usually through a lab at work or a lab at school, and you'd have to wait in line to get a terminal, and you'd be sitting there usually with dozens of other people, and sometimes you'd wait for hours. And by the way, before there was the web, you had That was your LinkedIn. All right. You would meet your future business associates in relationships there. You'd have conversations about, your homework and stuff. You have this common basis. But the only reason you'd even meet these people is because you had to just sit there in a waiting line, waiting for your turn at a terminal, which gets us back to the paper documents. Okay. These were all over the place, and you could access them without getting online, and that was hugely useful. You would be able to look up how to do all this stuff, and you'd take your notes, write it out on paper, and then when you'd get your precious little terminal time, you'd be all ready to go. Which is honestly like the inverse of today, where I think people just sit down, I'm guilty of it too, and just start typing without having any idea what they're doing. Now, maybe you could argue that, artistically, you could come up with things you would otherwise not have done if you weren't, so confined to have to figure out what you were going to do before you did it. Yeah, maybe. But honestly, you'd get your job done faster and have less bugs to remove if you actually learned something before you tried it, or at least read about it before you tried it. Now, even to this day, right, I still cherish these because these are where I learned how to write, my first C programs and actually use library calls to print stuff and open and read files and everything else. All that is in here. And I mean, this is all there is. I mean, if you want to install the operating system, fine. But as a student, we didn't have to do anything in the Red Book, which left us with ease. That's all we had. And this all there was. Look at this. This is actually an attainable goal. Not that I ever did, but by that I mean you could read all of these and know essentially everything that was in 1986 with respect to Unix. All right. This was pretty cool. Now I say Unix, but this is, again, remember, this is like BSD 4.3. There were other Unixes out there. Even then, AT&T had its System 5. Berkeley had its BSD 4. And everybody else had variations of these, most of which were variations of the Berkeley version because they were more than happy to let the source be available, while AT&T was less so. But you could get a license for it if you wanted to. But usually you'd get a license from AT&T, then you'd go to Berkeley and say, I'm already licensed to have access to Unix. Can I have yours for free, please? And they would say yes. And you would get all their extensions like TCP/IP, which was not in System 5, or at least it was an add-on in the later 80s. It was fundamental to BSD4. This is where the internet as we know it today really kind of evolved out of. I mean, yeah, it was a DARPA project and all that stuff, but where do you think the DARPA money went? It went to researchers at Stanford and Berkeley to implement the IP protocols inside of a, at the time, modern operating system so they could write programs to take advantage of it and really use it. This is really where it all started, and all that is right here in this manual right here. I'll talk about that one. I'll show you that in a minute. All right, so first get used to these names. URM, that's the Unix, that's the user's reference manual. This is a user's supplementary documents. Users are people that type things in on a keyboard and run commands in what we call a shell environment, or some people call it a terminal window or a shell window or whatever you want, whatever word you want to use. These are things you type in on the command line in Unix. The programmer's reference manual, PRM, and then the programmer's supplementary documents, right? These are for people that want to write programs, and at the time you wrote everything in C, or maybe Fortran, or maybe Pascal, or something like that. But for 99% of the time, you were writing C programs. That was the language at the time. Subsequently, you'd see a lot of C++, and then you'd see all the morass of today's languages and stuff like that. But inside of everything that you're doing, C++, Java, Python, no matter what you're doing, is hiding this, okay? So let's look and see what's in here first, okay? Many of the sections of the manual, by the way, start with a section that says Introduction, all right? So what do we got here? Notice this is Section 2, Section 3. We already saw Section 7, right? So why are they in these weird orders, right? Well, Section 2, as it says right here, this is the system calls and error numbers. What's a system call? These are the subroutines that directly interface with the operating system itself. So section 2, at least in 1986, this is the only things the machine would ever be able to do. You could use this however you wanted, but this is all there was. And this was readable. One human could sit down, maybe 2 evenings, or even one, and just go through this whole thing. When you're done, even if you don't understand it, you will have seen, and you can see inside here, this is send, whatever that means, right? Well, this thing says it is send to, send message, a couple of variations of a command, send messages from a socket. Here's some stuff in here, and then you've got a longer description down here. But if you ever decide that you want to send a message, whatever that might mean to you, you know that there's a command. You've seen it. You've read it. You know there's a way to send stuff. Well, what the heck is a socket? Well, guess what? There's another section in here that talks about what a socket is. You can look that up in here and find out which manual it might be in. In fact, there is a socket system call in section 2 that says here's how you create one. And if I fumble through here looking for SO, here it is. You can find out how do I create a socket so that I can use it with the send command. It's all right in here, okay? Now, in 1986, when this set of manuals was created, and this is my point, this is all there was, and these are short, simple descriptions. Today, all the same exact commands exist, but if you read the manuals for them, they're enormous. Because what happens is we've added more and more features to these commands. They still do the same basic thing that they did 30 years ago. But now they're way more complicated. So my point is, if you ferret out these older versions of these descriptions, you can easily understand them very quickly. And then you can learn the newer versions, I would argue, more easily than if you just dove into the newer ones right out of the gate. And the reason is because there's so many options and variations of the newer commands, or the newer versions of these same commands, I should say, that I get a little bit overwhelmed, and I actually know what the basics are because I've read this version, right? So you can easily get a toehold, and then you can say, all right, let's read the more modern version of this. I know what the fundamental aspects are. Let me read the newer one now. And I already got the basic terminology down and everything else that the more modern documenter might assume you already know while reading the newer version, which is super important when that happens, so that you can understand what's going on. All right, so while we've got the programmer's reference guide open here, what sections do we got in here? 2, as you saw the introduction to 2, those were system calls, right? Well, what's the introduction to section 3? These are C library functions. These functions are useful for C programmers, some of which might make system calls in section 2 in order to provide the services that you're requiring. What we're doing is we're writing up the levels of abstraction in the programming environment. You do all your work if you want to with the low-level system calls, or you can then use these higher-level library functions. If you're running a C program, this is your actual doc here, and then it makes them easier to use. There's more functionality. You don't need the operating system for a lot of work, but when you do, there's section 2. When you don't, you just want to have a nicer way to print something, for example, and format that. That's going to be over here, okay? Not directly provided by the operating system, in other words, but these are helpful commands. But again, we're reading the programmer's manual here, okay? Therefore, these are not command line things you'd type in. These are subroutines that you can call. Like, where's a common one here? Well, get opt or get login or something like that. How do you close a file, right? Here's a function called fclose. Look at that. Super simple. Just flush and close what they call a stream. This is for streaming I/O. You just say fclose, give it the stream handle, so to speak, and the description's simple. If you look at the modern version of this, it probably goes on and on and on about all kinds of other weird stuff that more modern systems do, but at its heart, it still just does this, accomplishes this simple process. You might need to think about more today than we did back in the 80s, but if you know this first, upgrading is much simpler. Okay, so that's sections 2 and 3. Then we got 3F. Well, guess what? These are the same thing as section 3 in general, which by default is C. F means Fortran. So here's a bunch of calls. You're going to see a lot of the same ones for the Fortran compiler. And then what do we got? What's in section 4 here? Whoa. There should be an intro page. Introduction to special files and hardware support. Yeah, this one's a little more complicated because 35 years ago, the hardware supported was very different than it is today. But there's still a section 4 in the online manuals for Linux and OS X, which is really originated in BSD Unix back in the day. And you can go into section 4 and read about how all the I/O devices work, or at least those that have been documented, right? So some programmers are not so kind. It looks like I've got some highlighting in here. I obviously was using this for studying at some point. What do we got in section 5? Oh my gosh, I remember doing this. Section 5 is a description of formats of standard and common files. In this part, a.out is the name of what an executable program is. I remember, I didn't remember when I did it. It must have been in the 80s. I remember writing a program that opened up an executable file and then printed out all this information about it. And inside here, it tells you for an executable program, how is it formatted on the disk? What are all of its parts? How does it work? And this is a beautiful, beautiful example of what I'm saying about how things were easy and now they're more complicated. How long is this? This is 3 pages long. This is everything for an A.out at that time. As time proceeded, we use other formats like ELF nowadays. I'll bet a book this big exists on how the ELF format works because it has all these optional things. And as you get into the optional things, some of the options are user extended options, which are ultimately never documented at all, and it turns into this morass of complexity. Anyway, section 4 is about file formats. What do we got in section? Section 4 was your devices. Section 5 are common file formats here, okay? And then they leave you some room for notes back here. I guess I was more into highlighting than writing my own notes back when I was using this manual. So those are the reference manuals, look like that. Here, let's look at the one for the command line. Here's section 1. Look at all the things you can type in on the command line here. And then what's section 6? Section 6 are games. All right. So here's the documentation on how to run the games. Now, most of the games are designed like, here's my favorite. Adventure should be in here. There it is. There's all the documentation for Adventure. And it closed with, by the way, part of the game is to figure out the rules of the game, right? Part of the game is discover its rules. That's what it says right there if you can't see it on the camera here. All right, so there's a bunch of game information. What's on section 7? I can't remember. Why? Because this is miscellaneous information, okay? And what's in here are things like, here's a table of all of the characters in the ASCII character set and what all their codes are, in this case, in octal. And the reason these are in octal is because octal played a big role in the early days because one of the popular machine targets for BSD Unix were DEC machines, and DEC liked octal. So if you were a DEC person, you used a lot of octal. Down here, of course, are the hex versions. Okay? I never really was a DEC person, so I never did the octal thing. It does show up from time to time, though. You need to know it's there. It's very handy to know. Look at this beautiful thing. Here's the user environment description. 1, 2, 3, 4, 5, 6, 7, 8. 8 environment variables. And these are the basics, of course. You can add more, but things were so much simpler. And you can understand why these are here, only because there's just a few of them. Then you go on to today, and there's 400 of these things. And so on. There's other things. Here's the file system. Where are all the files? Why are they where they are? What's up with that, you know? A nice diagram of that, and how to use the ME package, which was a macro package for nroff and stuff like that. MS macros, and so on. Right? Okay, users stuff, right? This is all sort of things that concerns people that type stuff in on the command line, right? If you're going to write a shell script, it's going to use these commands in here, not C programs or even like a Python program or something like that. Okay, so that leaves us then with these supplementary documents. What are these things all about, right? Well, this is going to be a bunch of papers that were written by various people that by today, these are legends, right? So what's the very first one? Unix for Beginners. Consider reading this. I recommend to my students to read this thing. This is a 1974 paper. I believe this is a reprinted paper from like a 1974 article in the IEEE or the Transactions, the ACM. I don't see a reference to it being shared by permission from such and so. Here we go. Previously released in Volume 2 of Bell Labs Unix distribution. Blah, blah, blah. Programmer supplementary documents. So this actually is not a big paper. Not a lot of pages in there. 1, 6, 7 sheets times 2. There's a dozen pages in here. Flip through this because it'll talk about why do we have a pipe? What does it mean to do a pipe, right? How does the cat command? What is the shell for? How are you supposed to use it? Why was it written that way? Incredibly useful if you're diving in after oh, I'm a genius because I know Excel or something like that. And then you say, oh, I want to learn how to use this Linux thing. And you're totally lost because you didn't read this. Okay. Trust me, this is a useful thing. And then a bunch of other papers. Let's just pick some at random. Here's how the desk calculator works. DC is a variation of an HP calculator. This uses what's called reverse Polish logic. And the reason they use that word is because the guy that came up with it was from Poland. BC is the one that I use. You see me doing this all the time on my calculator. This uses infix notation, which is a little more familiar if you are familiar with 5 plus 5 in order to calculate 10. DC with reverse Polish is actually postfix is another name for it. And you would say 5 space 5 space plus for postfix notation. You put the operators after the operands. And there's an enormous value in doing that. If you ever write a parser or get into computing, you'll know that. So here's how to read your email. Okay, all kinds of stuff in here. What else is this one? Oh, MH. Oh wow. Who grew up with MH? I definitely did. Look at all the doc on that. And no, I didn't read all of this, and I probably should have. This was enormously popular. I read the book. There was an article written, something like that, how to handle 400 email messages a day and still get work done. And 400 back then was a big number. Now you'd have to write a book that's called how to handle 1,000 or more. How to read network news. That's your Usenet stuff. All right, and how to use Usenet effectively. A lot of papers that would be useful to people that use the machine and type these things on the command line, all right? Programmer supplementary documents, volumes 1 and 2. Oops, watch out for the microphone. This is true and dear to my heart because this is where I learned how to do TCP. This is where I learned how TCP/IP works and how to write programs that send messages over sockets and stuff like that, like we saw earlier, the send message. And it's because there's a paper in here called the IPC tutorial, which I believe is section 7. Look at that. I can still remember. This was everything to me. I read this thing. Proof right there. Highlighting in here and stuff. I had to read through this a couple of times. Ooh. And before I really got what the heck was going on, the terminology was driving me nuts. But it's all here in a nutshell. Now, this is all IP4 based, and nowadays we all use IP4 and IP6. There was no IP5, by the way. That's like a reserved for custom user experimentation. And then chapter 8, more highlighting, is the advanced. It should be, right? That's the basics. Blah, blah, blah. Oops, I'm going the wrong way. Section 8, yeah, the advanced IPC tutorial. I read these two things. Wow, what an eye-opener. Everything on the internet, all the greats, everybody's name, every system, your Googles, your Facebooks, anyone who's ever done anything with the internet. And even Google and, of course, Facebook are built on other tools like the Apache. Now we call it Apache Web Server, which used to just be the NCSA web server, HTTPD. And, of course, the one from CERN that was written by Tim Berners-Lee. Anyone who wrote those programs definitely read these books, all right? Everything that you think of as the internet today, this is it right here. Those two chapters, section 7 and 8, that's all they're really, that's the whole ball game. There's a lot of, tutorials and stuff that have come out since, the Stallman books and everything else, and a lot more detail. But if you start with this, you've got the basics, you got the terminology, and you may not know how to use it yet, but you got a toehold. And that's my point. Short, to the point. And I didn't even know the other ones existed, by the way. Those came years later after this stuff. A lot of the stuff that we know today, this is all we had to go on. And it all works. The only real difference, I'm maybe oversimplifying, routing protocols and stuff like that have been proved since all this. But, IP version 6, the IP numbers are in the simplest of terms, bigger, have more digits, characters, whatever you want to think of it, than the IP4 ones did, because there's more hosts on the internet today than there was back then. And we just ran out of numbers. So they came up with a new numbering scheme, and they had to change all of the commands, but only ever so slightly. If you understand this, moving on to IP6 is very straightforward. If you run these this is a whole little test program. What is this one? 7A? Perfect. Internet domain stream connection. I still assign these to my students to this day. I say, open this up, read this, make it go. Now, these are old school. And this was written before there was ANSI C, by the way. Look at these command line arguments. These are the old KNR style things. Now, you can easily make the tweaks and make the upgrades. There are some data types that have changed a little bit, so you might get compiler warnings or something, or you might need to cast this as something. But basically, this is still the same thing, and it definitely will still work. Looks like they cut off the closed curly. Oh, there it is. It's way buried underneath the curly brace right there. Okay, so it's all still here. Gotta watch those. Gotta watch those publishers from messing up your work, guys. Anyway, yeah, that's what I started with right there. If you can send 10 characters out, then you can send 20. You can increase the complexity and so on. This is, of course, the code for. This is in the most core bottom level of a web browser. It has to open up an internet domain stream connection to a web server, and it has to send data and get data back in order to show it in a web browser. I guarantee you it started with this. And the web server would be the next one in here, right? Where this is much more than I expected to see. That's 7C. I'm looking for 7B. There you go. That's this code here that ends on this page over there. This is what a server looks like. And if you ever write a web server, if you start from scratch, you're probably going to literally type in this code right here and then just add more and more and more. A web server is nothing other than what you're looking at right here, plus plus a little more details. But at its core, this is what it's doing. It's going to wait for something to connect. So you're going to connect a socket, going to create a socket, then you're going to listen. Somewhere there'll be a listen. There it is right there. You're going to listen for web browsers to come along and say, hey, I want to exchange data. And then you're going to go into a loop that says read data from the, there it is. You read data from the web browser in this scenario, and then you're going to write data back. And you're going to have, this is a do-while loop. There's the do, and here's the while, the bottom driven. But it's going to read data, and in this particular example, reads it, and it's done. The critical difference with the web browser, or web server, I should say, is that you send data back to the other side. But you can easily extrapolate that once you've got your hands, and once you've got the basics of this part down. And I mean, it's so simple. It's a beautiful thing. Now, you wouldn't literally use that same code anymore because in the ANSI version, we've got a few more fancier things going on. But I would say 5 or 6 edits on that code, and it's still valid today. PS2, more of the same, just more papers, more documents about stuff that you can do and how you could do it. Berkeley FP, I don't know what that is. I don't remember what that is. What the heck is FP? Well, let's read the background. Functional programming language. Ooh. Maybe some variant of Lisp or something? I don't know. I've never used it. I can read it and know all about it. Rect 4. This is Fortran. Great. Lisp. Here's a Lisp manual. And what else is in here? Ingress. Ooh. There was Ingress, and then there was Postgres. Then there was something called MySQL, which I never really used because it always had all kinds of shortcomings, and then there were potential lawsuits, and I honestly don't know why that's popular today. I really don't. Postgres, based the same group at Berkeley, I think, created it as the upgrade from Ingress. And it's always been open source. It's always worked. And it's always had more functionality and features than MySQL. So, I don't know. All right, so let's go back to the System Manager manual for a minute and look up this command right here, FISC. What the FISC is FISC, right? File System Consistency Check and Interactive Repair. And this is all the doc there was. It's all you needed to know. If you had an error in your hard drive, you would FISC the thing. You had 3 options, B, Y, and N. No problem. Now, modern days, there's more options. And maybe, it's nice to have more options, but you then are left with a document that's much bigger than this. So if you read this one first, again, my point, read this one. It's a page and a half. You got the basics. And guess what? A lot of the modern options, you don't even always need them. This is 90% of what you need to know right here. All condensed way down. You could Google it, I suppose, which would then turn out, here's FISC 8. Now you know what 8 is. 8 is the section that has the system management commands in it. You got yourself an entire Wikipedia page and a whole lot of opinions on what you're doing here. You get lost in here. Let's take a look at FISC section 8. We have no idea what operating system this is for or what release it might be. This one says check and repair a Linux file system. Clearly, this is not the same one that we saw before. And look what's going on here. Now we have tons of options. This is the more modern version. You might want the more modern options, but now when you're poking through here, you got to go through all this to figure out what's going on. Instead of, look, let's start with the basic one, then add the more complicated things as we go. Again, you might argue, well, then go find a tutorial instead of reading a reference manual, because this is the right way to do a reference manual. You should have everything in there. And it's difficult to learn by just simply reading a reference manual. And unfortunately, there's a lot of times when the reference manual is all you got to go on, if you even have that. If the person who created the code even has enough respect to create a reference manual. And a lot of tutorials written by people that haven't really thought out what's going on, or they haven't even bothered to read the reference manual themselves, or they've got one for a different operating system than the one you have, or an older version, and you never know what's going on anymore. Oh my gosh. So it really helps a lot to kind of understand the context within which all this stuff is still going on today, 30, 40 years later. Wow, right? You know, there's staying power for you. These section numbers. Wow. Now, how do you read these things today? Well, I'm on a Linux system here. This is actually an Ubuntu 20 dot something or other release of Linux. But any Unix system that existed since, I don't know when, actually, probably since 1980, has a command in there called man. And if you don't know what man does, read the manual for the man command. Now you know what man is, how you read the manual online. So start with man. It's in section 1. Why? Because it's something that I can type in a terminal. It's a user command. And this tells you about the manual. And it tells you, oh, look, section 1 are the executable programs, or what we might call shell commands. Here's your system calls, library calls, C library calls, right? 4, special files are your device drivers, okay? Your file formats, so how things are formatted. We just saw that before. Games, miscellaneous, things like ASCII and stuff like that. Administration commands, section 8, right? And kernel routines, which is a non-standard add-on in section 9, which I've never actually read before. But we know that some of the sections have intro pages. So I can say man 9, because I want to specify what section I want to look at. Intro. And unfortunately, there's no intro in section 9. If I type man 1 intro, there ought to be at least one for the user commands, okay? It's very naughty to create custom local manual pages without a summary. By the way, there really should be an intro for section 9 on Linux, in my ever so humble opinion. But again, those sections that have it, it is probably worth looking at. And in the electronic version, you know, even if you're on the internet, your web browser, or you're doing this on the command line, what happens is, I mean, for me anyway, I become a little disoriented because these are all disembodied. When you're looking at it on paper, you can flip through I mean, it's in your face. Look, there's stuff to the left of where you're at now. And if you're not going to bother to take the 10 seconds to have a look-see at the first page of a chapter or a section in a book, then, you know, you're not getting all you can out of it, right? Or at least flip through there when you're looking for a function like Fisk, you're going to see other things nearby, like the F77 Fortran 77 compiler. And, you know, you don't need it right now, but your eye will see it. You might, oh, look, I didn't know we had a Fortran compiler, or whatever. Or maybe later on, it's totally subconscious, and later on you see someone talking about F77. Now, oh, yeah, I remember seeing that somewhere. It might be in the manual, maybe. I mean, that was just the way things were. Now everything is a precision, precise, tactical reference to game. I only want to know this one little tiny thing. And yeah, my brain is, what, it's too full, is it? Yeah, right. I met a lot of people. I can assure you their brains are not too full. My point is, you got room. And it can be quite useful to take note of that which is around you as you go. So what does it say about section 2? And of course, this is just on Linux. It might be other systems are different. Turns out most of them are very similar. They actually use the same exact files, probably, because once BSD gave away their source code, everybody probably just started with that. They may have enhanced them since. Obviously, they would if they added more functionality to the functions and stuff like that. So here we go, man. 2, system calls. And this is, you know, how do you use the operating system? If you want to directly interact with it, you can. And everything that you do ultimately does go in and execute all these things out of section 2. And this one's actually interesting. So this introduction to section 2 on Linux is a bit shorter than it is on the BSD manuals, because the BSD manuals, as you may have noticed when I was flipping through them, have all these return values in there. Now, they move their documentation, I guess, into error no. And again, that's what all these little numbers are on these parentheses in here. So you can say man 3, which we all know is the C library section. And there is all their documentation, what are all the possible return values are from various system calls. And it's actually interesting that the BSD one has more narrative after each one of these than Linux does. I don't know. I think we're retrograding, but I'm not going to diss Linux. I love it. I use it all the time. But honestly, I would have been just as happy with BSD all along. So here's the introduction to section 3. Introduction to section 4. What does Linux have to say about that? Special devices, blah, blah, blah. Very little to say about them. Yeah, this is like a nightmare. No matter what version of Unix, Linux, whatever, OS 10, you're using, you rarely get decent documentation on how any of the devices work. And of course, as anyone anywhere knows, even if you're running other operating systems, not even Unix, that drivers are a gigantic pain in the ass. Perhaps because no one documents them. It is just a crock. What do we got here? File formats and file systems. Let's see if we can see a dot out, because I think Linux will still run it. No, man, a dot out. If you don't, don't give it a section number. It'll search all the sections. Man, ELF, do they have the ELF thing? Yeah, okay. Linux uses ELF formats. I just happen to know that. If you go to the bottom of a man page, look at all that doc. A dot out was like 2 pages. Look at all this junk going on. Like I said, yeah, I want to learn by reading all of this. I'm more happy with my little short, brief output, please. Thank you very much. In, of course, Linux's defense, we now have shared object module. There's all these things that didn't exist in the 80s that all got added on. Start with the basics and then worry about the new add-on stuff. So down here it says C. My point is down at the bottom it says C also. You can see a lot of other things. I'm surprised they don't have other formats. I don't know. I read somewhere, like Linux no longer supports this, that, or whatever. And A dot out may have gone bye-bye. They got an intro on section 6. Yes, the games, all right? Funny little programs. And of course, they don't give you a listing or an index or a table of contents of the games, which is a bit of a drag. If you want to know where the games are, though, you go look at the file system, which I believe is user games, is where the programs actually are. Well, I've got Mahjong. No. This is the problem when we don't have paper. Because I can easily just flip to the next page and start seeing the games. All right? Again, my point. Where are we at? Man 7 intro. What do we got going on over there? This is the miscellaneous documents, you might remember. Like the ASCII page and ASCII. I use this all the time. Section 7 right there, okay? Table's a little bit different. Maybe they had a copyright issue or something. But again, it's still here and still hugely useful. Now, what do we got? Man 8 intro is going to be the system management stuff. Privilege commands. How does the system administrator do? Again, there's no index in here, which makes it a little bit annoying. What do we got? You can also see intro of section 1 for more information on statuses and error node we were poking around in a minute ago. Blah, blah, blah. And it closes with a little note that says, oh, hi, I'm part of the Linux project. I think all the Linux man pages look like this. And that's, by the way, what a man page is, okay? Man is because man is manual, and what you're doing is reading what used to be the paper ones that I showed you a moment before. So these are the manual pages. Now, let's say you want to know what all the manual page names are, and you've tried to find stuff, you can't find it. You can say man-k, and I'm now looking for a keyword, right? Maybe I can type man-k intro, and what we'll probably see are the introductions to all the sections of the online manual that have introductions, okay? Among any other introductions that might have crept in there, like introspect and so on, so it's actually getting more other words. There's a tutorial introduction to Git. That's great. I never even knew that was there. This is pretty cool. Hey, if you're one of my students, you might have a look-see at this. I'll add this to my list of references the next time I introduce Git to my students. That's pretty handy. Of course, this is going to be all the command line stuff because that's basically what you're. I mean, if you're going to write online manuals for interactive shell-based viewing, you ought to be talking at least about the shell-based versions of the commands. And there's even a part 2 in there. That's nifty. So I'll take some random pot shots and see what you can find. All right, so what else can you do with the manual? All right, let's say you tried keywords and things, you can't really find anything, and you really kind of want a more paper-esque experience, but you're on the command line. Well, what you can do is you can actually go look for the files that comprise the manual itself. I mean, after all, it's just listing files on the screen is what it's doing. They happen to be in here. User. Well, in the old days, it was in user man. That doesn't exist anymore. Now it's user share man, and the difference between user and user share is that in the old days, Unix was supported on the platform, and then when whatever the main machine was, like a VAX or a 3B20 or something like that, or at AT&T. Then, as they supported more and more different operating systems, or shall I say, more and more different hardware platforms, those items that were shared across all different platforms went into user share. Because user, which I believe stands for something like user system resources or something like that, there's a bin directory in there and libraries and stuff like that. And that is for the machine that you're on now. User share is, like I said, this is for all machines that might be related. So let's go up there and have a look around at what's in there, by the way. So what else? You got all sorts of stuff. You probably got, terminal capabilities and things. How do you move the cursor around on the screen, and libraries that do things like that don't have anything to do with the like the CPU per se, but it would have to do with things that are shared across all different kinds of CPUs. Like, for example, the man pages, right? They are good for all operating systems. Let's have a look-see at man 7. What's in here? Well, you can see these are all the actual files that you can list up, and they're named after the command that, if I said man libc from section 7, this is the file it would print on the screen. The fact that it ends in GZ means it's gzipped, but I can still open it up with less because less knows how to open up compressed files. So I could type libc star whatever, and what I'm looking at here. All right, this is the actual source code written in nroff. Let's say I don't know what I'm looking at here. Well, you can obviously type in man libc and have it formatted for you and print it up on the screen, and you're looking at the same file in a more human-friendly sort of way. And this tells you that this file, this library, contains all the executable object module code for all of the things that you can read about in section 3 and probably also section 2 of the manual. All right, and it'll tell you a little bit about where it came from and all this other stuff. Let's say you want to know what the heck these formats of these files are. I happen to know they're in nroff format, and they use the AN library package. So you can type in man nroff, and this will give you links to all the other parts and all the other stuff you need to look at. Nroff is a very sophisticated system with lots of libraries. This was how, like all the every one of the manuals I already showed you today was all written using nroff, or what we saw a variant called troff. The difference, of course, being that nroff is for screen printing and troff is for typesetting. And typesetters have more options that have to do with funky fonts and kerning and things like that. And they both use tons of libraries for formatting tables and all kinds of math functions and things like that. Now, with that said, I will conclude with the observation that, this documentation here, I don't like writing that. It'd be nice to be able to see what I'm doing while I go. On the other hand, this is not too bad once you learn how to do it. You don't really need to see what it's going to look like. I'm not an art major. I'm trying to write manuals for programmers. I think about information in the context in which what my words mean and related to the other sections of the manual. And this is actually, NROF is really a kind of a programming a language sort of way to formatting a document. PP is probably some sort of paragraph boundary. I think there's this would be, print that in italic or somehow emphasized. You don't have italics on your screen, so it might be, brighter or darker, depending on the kind of terminal, right? SS is probably some sort of a synopsis summary or something like that. If we type in manlib and then look and see down here, in fact, it's some sort of subheading. There it is. I believe that's what we're looking at, the other C libraries heading, right? So you can see there's little commands in there that have to do with how you're going to format the document. And nrof and trof are the commands that you use to create the output so I can see it on the terminal or print it on the paper. My point, of course, it being that, as a programmer, sometimes I like to think of my documentation and text as programs rather than something that I'm going to just poke around and peck at for an hour and a half with a mouse so that it looks okay. And then later on, when you have to make updates to it, it's a nightmare. Come on. Who hasn't been frustrated at Word when you're trying to add a new sub indentation level in a bulleted list and the whole thing goes nuts? It takes you an hour and a half to fix your document. Yuck, right? Why? Because you didn't think of it as a programmer. If you want to make a bulleted list with nrof, that's what all these little IR thingies over here are. Okay? Those should be bullets. Let's look at the first one on the page. IR glibc, and then we have an I, and an IR info libc. So if you say man libc, IR. Well, okay, so they don't have bullets. Why? Because my terminal doesn't have bullets. But it still works. It's it does whatever it can based on the definition of the terminal. This is indented, and it's a list heading. Okay, if you wanted to put bullets in front of them, I think you actually, I have seen them on the terminal, and what they'll do is they'll put like a dash over here or a plus or something like that, or sometimes they use a lowercase o to make it look like a round dot. But you're pretty primitive is the point with these, with a basic terminal functionality. Now this one lets you do bright and half intensity type things. It also has underlying. Some terminals don't have things like that. And as you go down in capabilities, they'll see different kinds of formatting, or none at all. It'll still do the paragraphs and align them. My point being that without bright mode, it may result to putting dashes or something else on the left. Again, all these references down here, we all now know. If you type, here's a great one I do wrong all the time. If you don't put the section in there, it finds the first one that comes along. And this is printf from section 1. Well, this is a command that you can type in a shell. And if I'm running a C program, this isn't the printf I want to see. I need to go to man3 printf. Okay. In fact, if you just type man printf, I should have shown you this. At the bottom, it probably says, see also the one in section 3, because you're probably here by mistake. Okay. So man3 printf is what you can then look at. And now this is the modern printf with 800 variations. And we probably have all sorts of options. There's a lot going on. And at least they give you a nice little example program down here that you can actually copy and paste out of here and run. And of course, see also all these other ones, if you're here and you want the one in section 1, right? So anyway, that's the general gist of the man pages a la Unix, which would be applicable on anything that, BSD, System 5, your next computer was, a BSD-ish derived version of Unix, and Linux is a conglomeration of both System 5 and BSD. OS 10 is really the natural evolution from Next Step, which Next was in the 80s, and OS 10 was 2003 maybe, when Steve Jobs went back to Apple, right? So in all those systems, and every common and popular system everywhere other than Windows has manual pages like this with these exact same sections, and they all work very similarly. Over the decades, there's been a lot of work to try and unify how everything works so programs can be portable, while the manufacturers, the profit-driven companies that create operating systems, be that Apple, Microsoft, are two huge names, are constantly adding and adjusting things so that they can achieve what's called vendor lock-in, sometimes, in my opinion, on purpose without any real value, other times absolutely legitimately so. The wonderful set of libraries in say, on OS 10 for user interactivity and creating, graphics and stuff like that. That is beyond Unix. Unix doesn't do that. It's just the operating system and the basic commands that you type in shell windows like this. And the vendors then added more, their graphics and everything else. Now, for a little description as to why Unix is the way it is, remember it used to be run in labs like this. Here's a photograph of Texas Tech, then and now. This is probably an article. Let's see what they got in there. That's obviously part of their library. Well, there you go. There's the picture we were just looking at. Wow. Let's see, open as an image in a new tab. Maybe get a better view. There you go. Look at these things. So these are basically what we would call dumb terminals or glass terminals, because before there were glass terminals, there were paper terminals and teletype machines. I had a video on my old Model 15 the other day, incredibly loud and slow. But these is what we had in the end of the 70s, early 80s. And these would have all been tied back with RS-232 cables to a Unix machine somewhere, or maybe a DEC back in those days. When I was in college, we had these tied into a Harris computer, which provided a virtual card punch and printer to a mainframe so that we could still use these basically inexpensive terminals. These look to me, I don't know what kind of terminal this is because I'm not familiar with the white keyboard. If the keyboard was black and this was black in a white box like this, I would say these look like Hazeltines. Or is it Hazeltine? I don't know. Let me know in the comments below how to say Hazeltine. Some more Googling around, get you some more photos. That's definitely a Hazeltine terminal right there. Absolutely. If we zoom in on this thing, maybe we can get a closer look at one of these things where I'm going to have to create an account, blah, blah, blah. Open image in a new tab. And zoom in, I'll bet you can see it in there. Yeah, I can barely make out that. It's a Hazeltine. We had some of these in one of the labs that I worked in. That's definitely a Hazeltine terminal. Anyway, my point is that's what I thought I saw on the other sheet, or on the other page. But the terminal, the metal down here was white, so I don't know what kind that other one was. What do we got here? Here's another lab photo somewhere. And this is actually very funny. Look at the title. Me and my TRS-80. Kids and their computers in the 1980s. If you look at this photo, there's not a TRS-80 anywhere in this picture. Now, granted, this photo is out of context. If you click this link, there's a whole article about all kinds of stuff, and there's other TRS-80s in the other photos over there. But, yeah, so this is, black background, black down here. That's probably a Hazeltine over there, and maybe over here as well. These things, I first of all guessed that it was a televideo, but you see that little thingy right there? That is absolutely going to be the brightness control on an ADM3A. So I'm sure that's what they're dealing with here. These two boxes, this little line down here and over to the left, could that be an Altair 8800? Is this how they did this stuff? This would have been in the 70s. No way would they do that in the 80s. Well, the Altairs would have been gone by then. Even the IMSI 8080s were gone. So I'm not sure what this is supposed to show. These old steel case discs. And yes, mine at NIU is still this kind. Oh, yeah, we still got a bunch of these. They last forever. Why throw them away? And now it's like retro chic, cool. I'm actually proud to have a desk that looks like that these days. It's just funny. And it has like a linoleum top on it. It's a beautiful thing. Absolutely fantastic. There's your government issue. Anyway, on these glass terminals is what I was talking about. This is where those manual pages would have been printed and used for reference when you had access to your terminals, right? And when you didn't, because your lab only had 4 for the 500 students that might have been in that high school there where these people are working, what are the other ones doing? They're reading the paper documentation and making notes and working out on scratch paper how they want their programs to work. So when they get the precious few minutes of access on their actual terminals, they can get their work done without stalling all the time. Which, I mean, again, face it, that's what we do today because we rush to the keyboard and sit here and just sit and think. And, well, that's okay because we're not, preventing somebody else from using the terminal because everyone has 5, right? So, I mean, I don't know. That's good. That's bad. I don't know. As far as debugging code goes, though, it usually goes a lot smoother if you actually think about it first and do a little bit of preparation before you write your code. So anyway, that's all I think about these old manuals. It usually goes a bit more smoothly if you put some thought into it first. So that's how the manuals work, and a little bit about the environment within which we use them on paper as well as online, what the old versions are like versus the new ones, and how you can take advantage of that. Thanks for watching. I'll see you next time.